Hi, I'm Alex Blackstock.
And I'm Spike Brem.
We're engineers at Airbnb. Airbnb is a marketplace that connects people who have space to spare with people who need a place to stay.
We provide unique travel experiences by connecting people around the world face to face.
In this guest lecture, we'll tell a little bit about the story behind Airbnb, the challenges we're facing at scale, and how we're using innovation. Before jumping into any of the technical details, I thought I'd give a little bit of context by explaining the foundation of Airbnb. This is my profile. I'm Alex. And this is what the homepage looks like. From beginning to end, the Airbnb online experience is meant to be a reflection of the product philosophy. So our assets, which are our listings around the world, feature prominently throughout. This is what a listing page looks like. You can see both the host and the listing that they're offering on Airbnb, as well as a lot of other information that you can use to help make a travel decision. So this is sort of a general overview of how we'll present things today. I want to start a little bit with the foundational story, talk a bit about the three founders, jump into the technology stack itself, and then I'll turn it over to my coworker Spike, who will talk about some specific technologies we're applying right now to move the product forward and sort of what we're thinking about for the future of a lot of our tools and services. And then at the very end, since it is the Hack Week video, we'll leave you with a few little nuggets of wisdom. So first, the foundational story. The three founders, Joe, Nate, and Brian, are pictured here in their dashing suit attire. The very beginning of Airbnb starts at an apartment on Rouse Street in San Francisco. This is back in 2007. Brian moves in with Joe, and rent increases dramatically. So dramatically, in fact, that they can't afford it. So at the same time, there is a design conference happening in San Francisco. And the attendees of this conference have a problem as well, which is that there's absolutely no vacancy in the entire city. So it's interesting. We now have two of our three founders, Brian and Joe, and they have a problem, which is that they can't pay their rent. And the attendees of this design conference have a problem, which is that they can't find a place to stay. So the two of them decide to solve both problems at once by blowing up an old air mattress, brushing up on their breakfast cooking skills, and a little bit of hacking later. airbnb is born. Skipping a lot of the various starts and stops, the difficult periods getting the initial site off the ground, suffice to say the idea behind airbnb grew very rapidly. So I'll skip now to a few images that we've produced in the past year or so that shows really how fast this idea took hold. This picture here is the city of San Francisco divided by block, and the red color of the blocks demonstrates the density of Airbnb listings. So in a span of 4 years, this idea became extraordinarily popular. And on an international scale, the story is much the same. From 2008 through 2012, the growth has been really unprecedented. Pretty much every graph that the company has produced in recent times kind of has this sort of a shape. Over 10 million nights booked at this point. It's a form of growth that the founders and people that have been working for any amount of time at Airbnb have had a really hard time getting to terms with. Operating at web scale just implies a different form of growth. So this growth is amazing for business. There's nothing bad about it. These are really good things to see. But with this extreme growth comes extreme problems. Things that are very hard to anticipate when you're planning on having a decade-long trajectory and you meet that goal years and years in advance. So with this growth, we have all kinds of problems in all kinds of areas. To highlight a few, in fraud, payments made with stolen credit cards, for instance, are an enormous problem and cost the company money when these fraudulent credit card transactions have to be paid back. It's, of course, also extremely insecure. Search is a very interesting problem for a company operating internationally that has properties spread all over the place. You have to incorporate many search vectors such as geolocation and calendar-based searches all in the same signal. As far as payments go, Airbnb transacts in 192 different countries, even in third world countries where access to electronic banking infrastructure is extremely difficult or in some cases unobtainable. But we have to support these people anyway. Trust and safety is definitely the foundation of the company, and this is a problem that increases with the scale of the company just like anything else. The sorts of combative measures that we've taken in the past include the development of a reputation system and various forms of identity verification, which, as you could imagine, are very difficult to standardize and to moderate on a global scale. Internationalization is another very key element. With 30 plus languages, it's extremely difficult to keep various aspects of the product feeling like a local experience. So localization, which is the process of bringing features in the site to feel much more natural, as though you were opening a page that was made by your neighbor, no matter where you are in the world. This process is really painstaking, requires a lot of research. You also end up with design challenges such as right-to-left languages and issues with static content such as images that contain words. All of these things need to scale with the 30 plus languages in the 192 countries. So obviously, the founders need to move to a bigger office. So we got a new space, and we started deploying some technology to solve this problem in a more effective way. So I'll just jump right into the core stack, the technology that powers Airbnb.com in the present day. By and large, Airbnb runs on what you might consider a pretty typical technology stack for a web startup, especially one that's experiencing a large amount of growth. It's a Ruby on Rails shop renowned for the speed of development and the ease of iteration. Hadoop, I do want to highlight a little bit later on. The context in which we're using Hadoop for its MapReduce capabilities are for primarily analytics, and we use technologies like Pig and Hive to inform business decisions. I'll mention that our use of Redis is very specialized. We actually use Redis not as a general key value data store, but for specialized queuing operations, such as our fraud queue and our photo uploading and processing. I'll skip for now and return later to the front-end technologies, CoffeeScript, Backbone, and the server-side component Node. I'll let Spike speak a little bit more about that later. We're big fans of Amazon Web Services at Airbnb. Our web servers are running on EC2, the database by RDS. These things have a pretty stock standard application, so I'll mention a few specialized use cases that we employ here. EMR stands for Elastic MapReduce, and these are the machines that run our MapReduce jobs. Having a managed service that's backed by Amazon's Web Services SLA is really an incredible advantage over deploying a MapReduce cluster and maintaining it on your own. DynamoDB is a newer technology offered by Amazon, and it sort of is a replacement in some sense for a traditional single machine key value store. It guarantees you infinite expandability and great failover. So we've incorporated Dynamo into a few house-built tools to form a more flexible key value store that has great failover and the ability to be distributed. We also employ a few exotic technologies, and there are some special use cases that these things help us to solve, and some general use cases that help us manage our ever-growing cluster and herd of machines. Zookeeper is a innovation that we have been making great use of. One major decision that we made once our core application grew very large was to break it apart into multiple services that handle specialized parts of the booking and navigation process. Zookeeper is a service that helps us coordinate these machines and helps them discover each other without the overhead of explicit management. Another point very much worth mentioning is that Chef, our deployment system, is really an ecosystem all to itself that helps us move as fast as we do. Deployment, especially for a very complicated and multifaceted web application, can mean the difference between fixing a bug on time or not. It can mean the difference between extended downtime and not. So having a robust, easy to use, fail-safe deployment system has been really key for us to be able to move confidently and quickly in our product development. We have several different variations of search at Airbnb, some internal and some external. Our sort of core search engine, Lucene, is what's actually returning listings when you search on the main site for somewhere to be. Besides that, Sphinx is a really great open source project. It's a full text search engine that we use internally to index a lot of different documents and database records in a very specific way that doesn't require so much of a modular and general purpose search engine. I'd like to turn it over for a little while to Spike, who's going to talk more specifically about some projects that we're developing on our own to bring about the next generation of scalability in our web applications.
All right, thanks Alex for that introduction. So I'm Spike. This is my Airbnb profile. I'm a front-end engineer here at Airbnb. I joined about 2 years ago. And what I want to talk about today is web apps. So here's airbedandbreakfast.com circa 2008. It looks great, right? Beautiful design. This was our original Rails app. And so if we take a look at airbedandbreakfast.com, so like I said, it was started in 2008. It was a Ruby on Rails app. I believe it started off Rails 2. For a long time, it was a Rails 2.3 app. We recently had a very painful upgrade to a 3.0, and that's a whole story for itself. But it's no easy task. But we're still stuck in this like traditional page-based paradigm because that's what Rails is all about, right? Rails is an MVC framework that's fashioned around the controller and the action. So the whole idea is that you've got your web app, you click a link, and then it brings you to a new page. You click a link, it brings you to a new page. And so, Rails is really popular and it's really well developed and it's a great open source project, but I think it's been around for maybe 7-8 years now, and it's really good at solving the problems of the web 5 years ago, but it's not entirely solving the problems of the web today and tomorrow. And so I want to frame this in terms of the website versus the web app. And so here's a little diagram of what I'm talking about. So in my estimation, a website is like the classic idea of like the 1995 web, right? So the client is very thin to infinitesimal. The client would be like the part of the application that runs in the client, so the JavaScript. And then the server would be very large, the bulk of it. And so your application almost entirely runs on the server side, whether it's Rails or Python or Perl or PHP or Java. Your application runs on the server and it serves up static HTML to the client. And then maybe there's some jQuery sprinkled on for animations or whatnot, but it's not very interactive. That's what I call a website. And then a web app is the idea, or what I'd like a web app to be these days, is that the client is very fat and the server is very thin. And so more and more of your application logic is moving to the client, and it's becoming, for a variety of reasons, which I'll get into, but the client is becoming more robust and thick. And then the server can be even a stateless set of APIs even. And I also see this as the battle between the past and the future, where back in the day, the web was all based around request and response, static HTML, but more and more we're moving towards this like more native feeling application. So there's a couple different names for this style of app that I'm envisioning for the future. You'll hear some people call it a rich client app, or a fat client app, or a single page app. That's kind of my preferred terminology for like a rich JavaScript application. And so what is a single page app? The classic example would be Gmail, and probably the first big example. I think it's really amazing what Google was able to accomplish all the way back in 2004 on like Internet Explorer 7 and 8. I don't know if 8 was even out yet, but I do remember that they were very controversial for not supporting Internet Explorer 6. Good for them. But this is the classic example, right? You load the app, you navigate around, you never get a full refresh, a full page refresh. It's always redrawing content and then fetching data without a full re-render. And I think a lot of us are still aspiring to build a Gmail style app. They've really killed it. So, like I said, in a single page app, you navigate around the app without a full page refresh. There's a ton of application logic in the client rather than on the server. There could still be some in the server and APIs and things, but there's tons of logic in the client. And then the application can fetch data on demand. As you navigate around the app, you fetch more data to render new templates and new views. So you may be asking, how do you build a single page app? What is it comprised of? And the answer these days is JavaScript, whether you like it or not. This is the semi-official JavaScript logo. JavaScript is funny because it was created really quickly by Brendan Eich from Mozilla, and it's maybe not a very fully featured language or a very pretty language, but it's kind of ironic that today it's become the lingua franca of the web. So more and more JavaScript is the primary language. I mean, it runs on every platform, and even JSON, JavaScript object notation, started off as just a subset of JavaScript, but now it's like the main data format superseding XML. So it's kind of interesting. So why now? I mean, why is JavaScript big now? Why can we build these single page apps? So I think the number one reason that we're able to do this is because of faster JavaScript runtimes. Google has really led the charge, but really there's been a browser war in the last 5 years or so, and you know who's won? It's been the consumer. So Google has V8, which is their JavaScript engine, which they've built into Chrome. It's probably the fastest or one of the faster JavaScript engines out there. It not only can it compute really fast, but it can handle a large amount, tens of thousands of lines of JavaScript code at a time, which hadn't been possible in the early web. Also, besides the language itself, there's all these new browser features. Things like push state, local storage, session storage, WebGL, you name it, WebRTC, there's a bunch of stuff. These are all under the umbrella term HTML5. HTML5 itself isn't really a thing, but all of these new features are being created so that we can build web apps that function and act more like native applications. And then finally, heightened user expectations. So, once your user has started to use Gmail for a little bit, or Google Docs, or any of these, and then they come to your site and it's just a website instead of a web app, they're not going to return. And this could mean the difference, especially if you're starting a new app, a new company, this could mean the difference between success or failure. Because if you don't have a really snappy, engaging user experience, then someone else will, and then they'll beat you. So here's how we did it, or how we do it today. So we've been fairly successful with Backbone.js. And of course we've got a number of Rails apps that form the backbone of our website. And Backbone and Rails play together pretty nicely. So if you haven't had the chance to check out Backbone, I highly suggest it. It's becoming kind of a standard library for the web, similar to how jQuery is now a standard library. And a lot of newcomers, some people that we interview, they don't know the difference between JavaScript and jQuery because it's such a given these days. And I think Backbone's trending towards that as well. So basically what Backbone is it's a library that provides structure to your JavaScript, to your UI JavaScript mostly. And it's an MV star library. What is MV star? So it's kind of funny. A couple of us went over to Backbone Conf in Boston last May, and there was this is when I first heard this term MV star, because some people call it an MVC framework or MVP, where P is presenter, or MVVM, which is model view, view model. There's all these different names for it, but basically everyone just settled on call it MV star, and let's get on with this. And the classes that it provides are Backbone View, Backbone Model, Backbone Collection, and Backbone Router. And these are all basic building blocks that you can use in your application to give it some more structure. Because one of the realities with JavaScript is there hadn't been a whole lot of great libraries, especially for the client side, until recently. And so people had these giant spaghetti code jQuery monstrosities, which were a nightmare to maintain. And there's been a number of different frameworks throughout the years, Dojo and MooTools and these things, but Backbone has really caught on because it's easy to understand. So you can read the whole page of documentation in like an hour or less, and I think it's now like 1,400 lines of code, which with tons of comments. So it's very easy to grok. And the whole idea with writing your apps with Backbone or something like it is to think about building an application rather than manipulating HTML. So back in the day, a few years ago, you could create these dynamic apps, but you'd really be thinking about, okay, let's put an event handler on this element, and when the user clicks this button, we'll go fetch an AJAX request and stick the HTML that we get back in this other div. And that works, but it's not very maintainable, and your code is like way too tightly coupled. And so with Backbone and similar libraries, you can build the right abstractions so you can build more maintainable applications. So I'll walk you through a few of the Backbone apps that we've built in the past year or so. This is our biggest one so far. This is called Wishlists. You can go to airbnb.com/wishlists. But it doesn't look very exciting here because it's a static image, but it's a full push state app. I forgot to mention what push state is. So push state is the idea that when you can programmatically with JavaScript change the URL in the browser without triggering a full refresh. And so what that means is as you navigate around the app, you can rewrite the URL without a hash bang or anything in it. And then when the user refreshes, they're on that new URL. And then you can also share that URL and things. And so Wishlist was a big one. It's very dynamic. As you navigate around, it'll load new data, and it's very snappy. Here's another one. This is our search page. We've redone it using Backbone. Before it was a mess of spaghetti code, and it's much easier now. This is a really good use case for the Backbone collection. This list here. And then another big one is our mobile website. And so this is a single page kind of native style app. And it provides a really good user experience in my opinion. Okay, so now I want to talk about the easy way versus the hard way. So this is a terminology I've come up with, and it describes different ways to build single page apps. So the easy way, this is the way we've done it. This is the Backbone plus Rails approach. And so what this diagram is trying to say is if we've got the client and the server, and so most of the application runs in the client, the bulk of it. So there's routing, view rendering, your model layer, internationalization, currency formatting, all that kind of stuff. And the server is, for the most part, just kind of stateless and dumb. So it serves static assets. I mean, that could even just be S3 if you wanted it to be. It serves some static assets, maybe just some logging. And then the client would communicate with an API. Now I'm treating the API separate from the server for our purposes, but the API is of course a server somewhere. So the idea is that the client, the application running the client, would communicate with the API for all persistence and things. And so that's the easy way. Now, to reiterate, so it's a JavaScript app that runs entirely in the client. It's server technology agnostic because there's no real hard coupling between the client and the server. So, you know, it could be Perl, it could be Pascal on the server. It doesn't really matter. But because all of your HTML is rendered in the client side with JavaScript, there's poor SEO, and it's not crawlable by search engines. So, you know, the way the web was supposed to work, and for the most part, the way that Google still treats SEO is when it asks for an HTML page from a server, it expects a full page of HTML. So it judges all of the SEO based on the HTML returned from the server, and that doesn't fit well with these more modern client-side apps that render everything in the client. And then finally, there's a performance hit with this approach, an initial performance hit, because before the browser can render a single bit of the UI, it has to download a big JavaScript file, I don't know, maybe several hundred kilobytes, and then it needs to evaluate it, and then sometimes it even needs to make an API call, and then it can start to render. So you're serving up a basic, like, blank skeleton of an HTML page, and then you download all this JavaScript and start to render. And that can have a real non-trivial effect on performance. And Twitter actually wrote a blog post about this maybe 6 months ago, and they used a really interesting metric, which is time to tweet. And so they measured how long it takes from hitting the page to being able to actually interact with it and tweet something out. And you may remember that a couple of years ago they went to this really newfangled approach with the hash bang in the URL. You remember that? Like twitter.com/ hash exclamation point someone's Twitter handle. And that was really cool because it was all rendered in the client. But what they realized was there was such a big performance hit. And so they migrated everything back to the server to render on the server, and then they found a 5-time decrease in the time to tweet. And that's dollar bills, y'all. Like, that's money in the bank. And, you know, performance is often overlooked, especially in a quick moving startup, but that's the difference between being your competitors and not. So let me describe the hard way. So the hard way is something I call the Holy Grail, because it's something I had dreamt about for years and had never seen until just recently, and I'll get to that. But let me describe the hard way. So the idea is that the bulk of your application can run on the client or on the server. It can be agnostic to if it's on the client or the server. And then, you know, there's some things that, of course, are different on the client or server, but the idea is your model layer or your view layer or your templates or your, you know, date formatting and all that stuff can happen on either side. And then they both communicate with the API in the same way. And so your, routing, rendering, business logic runs on both sides. And what this allows you to do is you can re-render in the client. You can have these really fast re-renders within the application using push state. So you click around, it'll change the URL, but then instead of going all the way to the server, it'll just re-render the client. But then, if you were to hit refresh with that new URL, the server would return you that exact same page of HTML that was rendered in the client. Now that's really interesting, right? I mean, that's the way the web should work. The web should work when you ask for an HTML page, it should give you the full HTML, in my opinion. And then it's the special sauce that allows it to re-render in the client after that. And now this provides good SEO on top of the good user experience, because when Google or Bing or what have you crawls your site, they'll get the real HTML back. And SEO is also something that's very important for us and for a lot of your own startups. Like you can imagine, we've got all this really interesting content on the site, and it needs to have great SEO. And finally, the initial page load is very much quicker. And it's interesting. There's like perceived performance and real performance, and it is faster in real performance terms, but it's even faster than that in perceived performance terms. Now, what do I mean? So, when you request a page of HTML, the first thing that you receive back is like the raw HTML, right? And then the browser will go through line by line and parse it, and then fetch additional resources. So, what we do is we'll stick the script tag that links to the JavaScript file at the bottom of the page. So the first thing that happens is it downloads your whole HTML page and renders that for the user, so the user sees a page right away. Now, the browser may still be waiting for that JavaScript file to load, but the user can see it, they get acclimated, they can navigate around, and they can even click on links. Now, because we're using real URLs, if they were to click before the JavaScript app got initialized, or in other words, before the JavaScript was downloaded, then because you're using real links, that request falls through to the server, and then they'll get another page back. So we don't lose anything. But even when the rest of the app is still initializing, they can see it and interact. And then the JavaScript gets initialized, and it's a single page app, and it re-renders in the client, and it's very snappy. This is the holy grail, which I've been just dying to see for the longest time. And so today, enter render. So render is Airbnb's solution to this. It's something we've used to build a few apps, and it's something that we'll be open sourcing parts of in the coming weeks and months. So stay tuned for that. But so here's what it looks like. We had Backbone.js plus Rails, right? That's that we had built things in the past. Now we're going to replace Rails with Node.js. You've probably heard of Node.js. You may or may not know what it is, but basically it's a little wrapper around Google's V8 JavaScript engine, which runs in Chrome, and it allows you to run JavaScript on the server, and it's very fast, and it provides bindings to the operating system for things like I/O and networking and stuff. And so the general idea of render is we're going to take Backbone and we're going to pull it back to the server. We already know Backbone. We already have Backbone apps. We understand how to write a Backbone app and those conventions. What if we could take those Backbone models, Backbone views, Backbone collections, and use the same code on the server? So the whole idea is that you can write your application once, and then it can run on either side of the wire, and maybe you could even optimize it such that certain parts run on one side, certain parts are on the other side, or whatever. It just gives you such flexibility if you're just writing your application in one language in one way. And so then your app can run in the browser or in Node.js, agnostic to which environment it's in. This is the idea. So this might look familiar. I showed this to you just a few minutes ago. This is our mobile website, m.airbnb.com. So this was a Backbone plus Rails app when we first built it. But now it's actually running render in production, and it has been for a couple months now. This is the app that we used to prototype render. And it's interesting because we had this Backbone app, and we just converted it over. We had to modify it in a few different ways, but for the most part, it's the same app, but it can run on both sides. Check it out today. You'll notice that if you hit m.airbnb.com, it renders the whole page first, and then you can click around. You should try it out on your phone. It's really fun. And then here's the next one, which I'm just in the middle of building, and we'll be releasing soon. This is our new help center, and this is also a render app. So I think you guys should check out the blog post. Here's the link at the bottom here. Our blog is nerds.airbnb.com. It has a detailed explanation of render and some code samples and some things. Check it out. Coming soon. Now, there are some other projects. You'll probably be asking me, well, what about these other JavaScript projects? There's Ember is a popular one. Derby also promises to have rendering on the client and on the server. And Meteor. Meteor is interesting because it's one of the only open source projects I've ever heard of that has raised like $11 million in venture funding from Andreessen Horowitz. Interesting. The Meteor guys are a real talented bunch. A lot of them came from Asana, actually. So I want to break down some of the differences between Render and these other projects. So Ember, so far, Ember.js, that came out of Sprout Core. That's a really robust client-side framework. So I would call Backbone a library, just a set of tools which you can include into your application and build on top of, whereas Ember is a fully fledged application framework. It's more like 20,000 lines of code, but it's very powerful. You're kind of all in with Ember, where Backbone you can sprinkle things on top of, but I'm really interested in to see where Ember goes, and I think it's a great choice for really immersive single-page apps that don't have to have any rendering on the server. Although, at one time at an Airbnb happy hour, I was talking to Yehuda Katz, who is one of the main contributors of Ember and also used to be on the Rails and jQuery core teams. He was saying that they're toying around with a way to render the views on the server too. So I wouldn't be surprised if a lot of these efforts coincide. And there's Derby. Derby, you might have seen in Hacker News or whatever. So Derby and Meteor are kind of analogous frameworks. So they're both Node.js application frameworks that are very centered around real time. And that really influences their design. And so at Airbnb, we're not that concerned with building a real-time app yet. We might build certain parts of it, but through and through, Meteor and Derby are real-time. And you're very much tied to writing your data model in their way and having it live in Mongo. Now we already have a bunch of data, a bunch of other APIs, and we're not interested in converting that all over to live in Mongo. But if you've got a greenfield app, if you're starting fresh, it's an interesting way to go. I initially thought that we were going to use Derby. Actually, you can go find a tech talk from September. Excuse me, at airbnb.com/tech talks. We've got videos of all our talks, but I talked in September about this problem and the easy way versus the hard way. And I was thinking that at the end, my conclusion was, well, let's use Derby. But then I started to look into it, and it's not quite ready for production use. And then Meteor is kind of analogous also to Ember in the sense that it's very much an application framework. And I was fascinated by taking Backbone and taking the Backbone approach, which is like a small library which you can build on top of. And so I hope you guys are excited to see where that goes, and check out our blog for more updates on that. And I'll hand it back to Alex. But first, I just want to say that I'm really interested in web apps, and I think there's a lot of interesting things happening in web apps today and tomorrow. But where it's so relevant for you guys, because if you're building a startup today, it either is a web app or it has to have a web app component. I mean, there's no two ways around it. A lot of startups are analogous with web apps or mobile apps, and so it's really important to be able to build a really beautiful, snappy, fast, scalable web app, and it's just so exciting because there's so much innovation happening today.
With a little bit of backstory about the past and now a quick glimpse into the future of technology at Airbnb, I thought I'd close with a core principle that's really driven us forward through projects thick and thin and really helped our engineering efforts be quite manifest and quite team-oriented throughout the years. Of course, being Hack Week, we have to tell you to never stop hacking. What does it mean to never stop hacking? At Airbnb, hacking and the hackathon, the format, is very important to our culture. I thought I'd just break it down into a few bullet points that I think really exemplify the kinds of work and collaboration that our team experiences when working together. All of these things sort of wrapped up and encompassed by the idea of hacking together. Technological vigilantism, what is this? To me, this is the idea that there really, really is no reason not to try something that you think is going to be excellent. And if you can do it in an environment where you both have the desire and the license to do so, why not? Why not spin up the new database technology? Why not try a new approach at API design? Or a really crazy browser hack? You just never know until you spin it up and give it a try. Cross-functional collaboration. The hackathon is a great format for getting to know the workflow, the methodologies, the thought process of people in disparate fields. At Airbnb, our hackathons consist of teams with engineers, designers, producers. Just about any role that goes into the building of a product is a welcome and expected addition in many cases on a team that's going to put together a small hack, a medium hack, or even something that may turn into part of the product itself. Creating and learning together. I really want to emphasize the together part of creating and learning together. It's an all too common phenomenon that engineering becomes a siloed effort. Even within pure engineering organizations, small feature teams and people who are maintaining a very small amount of code can often become sequestered. And it's not that one can't work well alone or efficiently, but the breadth, the range of ideas, the kinds of innovative solutions that you stumble across working with other people who are breaking down the problem in a different way is quite amazing. The fact that you're with anyone else at all means that your product at the end of your hack is sure to be more than the sum of its mental parts. We wanted to leave you with a short video from our very first Hack-Airathon.
So picture this. On Friday night, we have a meetup with the community. We launch a voting tool where they can submit ideas on how to make the site better.
Tonight, you can submit your ideas and vote for them. In fact, we have an event tomorrow night where we might build one of the top ideas.
And Saturday, we have the hackathon.
Waltzing in at 7 p.m. and there being 2 sushi boats and a gigantic countdown timer on the table. You could sort of have this nice little foreshadow of your next few hours. It's going to consist of good food and some intense clock counting.
We're going to try to encourage people to work together, so if you don't have a partner yet, you should try to match up with someone so we can all collaborate on awesome stuff, especially designers, engineers, working together, because that's really what distinguishes the way Airbnb does hackathons versus other tech companies.
Deal is be 12 hours, so by 8 a.m., we're all coming back to here to the first Hack-Airathon.
People have so many ideas here about ways to improve the product and the service, or it's kind of zany, whimsical ideas. And the hackathon was our time to build those.
So it was me and Spike working together. We work together on a couple of other projects now. We've got a pretty good rapport.
Why we're going to be so good tonight? You notice we've got a splitter. And we're rocking out to the same tune.
So we kind of knew how to hit the ground running.
Everyone kind of has their pet project that they are really excited about.
I feel like it's really rare that you both have the license and the desire to go do something crazy, and everyone was on board with that, and it makes you feel really unbridled.
We have about 11 hours to go. People are cranking away. We got people working on search stuff. We got people working on community stuff. We got people working on internal tools for the team. It's gonna be awesome.
When our chef's away, lights come out to play, and so we ate a lot of junk food all night.
It was a mariachi band at midnight. You know, how many hackathons have that?
amazed at what you can get done when you have a deadline. You're sort of forced to show something.
Still pretty rough. Gotta see what else breaks first.
It forces you to be creative in the last moment.
That's a little sneak preview. Once we solve this problem, it'll be awesome.
I was exhausted. I just wanted to sleep.
7 a.m. at the end of the hackathon. We're all exhausted, we're bleary-eyed, but everyone is super excited about what they had been working on all night. I was absolutely blown away by some of the stuff our team had produced.
It was great, kind of the reveal at the end when you got to see what everyone had been working on.
I was very proud of what our team had done, and tired.
Well, I mean, that was the first hackathon. It certainly isn't the last. I'm really excited about the next one, and maybe it'll be opened to the community.
The hackathon has actually become quite institutionalized at Airbnb. We really enjoy it and try to do these about once a quarter.
Thanks for listening. We hope you gained some valuable insights into the challenges you'll encounter when your startup scales.
And that you're as excited as we are to start building the next generation of web applications.